Hi, geometry class. I'm doing a video for 2-6. Sorry I'm late. I was thinking that you weren't doing it till tomorrow, and I realized that you're doing it today. So I'm going to help you out a lot with lessons 2-6. I'm going to do the lesson quickly, and then I'm actually going to go over your homework with you so that we make sure that everyone's on the right page. I'm doing this outside, so you might hear birds and things like that going on, so just bear with me. My whole house is full of people. So let's start up here. This is 2-6. I'm trying to grab my pencil, but it's not letting me. This is planning a proof. We're not actually doing anything different than what we've already done. You can read in your book 2-6 some things about planning a proof. I don't think it's very helpful necessarily. It just tells you to draw your diagram, write your columns, mark your pictures, things like that. We've done most of that. So we're going to go on. Basically, in this section 2-6, we're going to learn two new theorems, and we're going to prove one of them. And then after that, I want to do a quick review of our theorems and postulates. And finally, I'm going to go over the homework for 2-6. Now, after 2-6, it all is review. We're going to take a whole week next week just to review and to do an SAT test. So hopefully you'll catch up and you'll get the groove of what we're doing in this book. It is definitely different than how you've been thinking before. It has a lot to do with memorizing theorems, definitions, and postulates. So on your next test, we might have, I'll give you a study sheet, of course, but on the next test, it'll probably be about just memorizing the definitions, theorems, and postulates and applying some of the principles that we've learned in these chapters. So quickly, from 2-6, there are two new theorems. Theorem 2-7 says if two angles are supplements of congruent angles or the same angle, then the two angles are congruent. So basically what that's saying is if you have two congruent angles, so let's just do, we'll do this here, 1 and 2, and they are supplements of each other because they lie, of course my line doesn't look straight, but 1 and 2 lie on the same line, so we know that angle 1 and angle 2 add up to 180, and by the definition of supplemental angles, two angles that add up to 180 are supplemental. Now if I had another angle just floating down here, and we'll call this angle 3, and angle 1 is congruent to angle 3, then we know, according to this theorem, that angle 2 is also going to be supplemental to angle 3. I mean, it just kind of makes sense. If this one is 50, and this one's 130, and this one's 50, then we know these two are going to be supplemental. And the same thing here is if two complements of congruent angles or the same angles, if two complements of congruent angles or the same angles, then the two angles are congruent. So it's the same thing, only this time we're talking about two angles that add up to 90 degrees. So let's quickly prove Theorem 2-7. That's really all there is in this whole lesson. And then we will go on to the written exercises, and you can follow along. Hopefully you tried them first. You can pause the video, try your homework, and then come back and watch my solutions. So prove Theorem 2-7. It says angles 1 and angle 2 are supplementary, and angle 3 and angle 4 are supplementary. We're going to prove that angle 2 is congruent. Actually, it's given. Congruent. Angle 2 is congruent to angle 4. We're going to prove angles 1 are congruent to angle 3. They do give you pictures in the book, so let me just do the pictures. We have angle 1. Here, that's a lot better, isn't it? There's angle 1. Let me draw the angles, and then I'll put the numbers in. And then here's angle 2, and you're going to see I'm drawing them supplemental, even though they're not on the same line. They're just telling us that they're supplemental. And we have this one and this one. And we have this one and this one. Okay. So let me draw the numbers in here for you. So we have angle 1, 2, 3, and 4. So let's mark in what we're given. We are given that angle 1 and angle 2 are supplementary. Supplementary. That means we know that angle 1 plus angle 2, because they said that by the definition of supplemental angles, we can add those together and they're going to be 180 80 degrees, and we know that 3 and 4 add up to 180 degrees. They also give this little tip that angle 2 is congruent to angle 4, and we're going to prove this. So the first thing we're going to do is we're going to write our given angle 1 and angle 2, angle 3 and angle 4, I'm just trying to make this shorter, are supplemental to each other, supplementary to each other, and that is given. So we'll fill that in. Because they're supplements, we can write on the next step that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. And we know that the measure of angle 3 plus the measure of angle 4 equals 180 degrees. And that is the definition of supplemental angles. So we just put like that, and that's how we know that. All right, now we've done this many, many times. Because these are both 180, we can set these two equal to each other by substitution. Measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4, and that is just substitution. We're just taking this and we're putting it in for that 180. So this is substitution. If in doubt, just say substitution. All right, so now we have this line right here. So we're also given that angle 2, I'm going to put this up here in the given. The book tries to, oh, they do it here, so I can do this. Measure of angle 2 is equal to the measure of angle 4, and that's given. Usually you can put the given all in one step, but they're just putting it up there. And I am going to substitute. They don't put all the steps in sometimes, but I'm going to put them in. We can say the measure of angle, since 2 equals 4, we can say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3. And I'm going to replace, instead of 4, I'm going to put this 2 up there. Measure of angle 2, and that's just substitution. I told you we use that one a lot. And then finally, we can subtract the measure of angle 2 from each other, and we'd say the measure of angle 1 equals the measure of angle 3. And we can also say measure of angle, we could say angle 1. Angle 1 is congruent to angle 3. This book lets you just do that all in one step, and the reason for that is the subtraction property of equality. So, or the subtraction PO. Okay, so that's it. We proved our theorem. That's all they have in the chapter, and then they go right into the written work. Before we go into our written work, I want to go back and just look at some of the theorems and postulates because I think it'll be helpful. They have them listed in the back of the book, but you should have them written in your notebook. I'm going to be doing a notebook check at the end of the month to see how your definitions, theorems, and postulates look because they're very important. They all start blending together, and you have to know them pretty exactly. All right, so I'm going to do some of the ones that are very popular that we're going to use. Postulate 2 is a segment addition property. It says if there's a point between two other points, then you can add the segments together to get the bigger segment. There's also the angle addition property, which is the same thing, that says if a point lies in the interior of an angle, then the two little angles are going to equal the big angle. And here they add this extra bonus part. It says if it's a straight angle, if the big angle is a straight angle, and you have a point in between, then those two are going to add up to 180 degrees. Let me just look down through here to see if there's any other ones. Okay, those are the ones, these are the two I'm pretty sure that we use most often. We don't use many other postulates in our proofs. Okay, let's go to theorems. I don't have a page of definitions. They don't have them in the back of the book. The definitions are all listed separately. All right, so let's get down to the midpoint theorem. The midpoint theorem says if M is the midpoint of segment AB, then the little segment is half of the big segment. So that's a popular one. The angle bisector one is similar. It says if BX is the bisector of an angle, then the measure of the big one equals, the little one equals half the big one. Of course, you're going to use this one all the time. Vertical angles are congruent. Here's some new ones from this chapter. If two lines are perpendicular, then they form congruent adjacent angles. So just think of it. If two lines are perpendicular, they form a right angle, so they're going to form, this one is going to be the same as this one. If two lines are perpendicular, it's going to be two right angles, but they just say congruent adjacent, which means side-by-side angles. Then they reverse it. They say if two lines form congruent adjacent angles, then the lines are perpendicular. And 2.6 says if the exterior sides of two adjacent acute angles are perpendicular, then the angles are complementary. So they're throwing another one in. If they say that these are complementary, that means they're going to add up to 180 degrees or 90 degrees. Then it forms then we know that the lines are perpendicular. And then if two angles are supplements of congruent angles or the same angles, then those two angles have to be congruent. We just did these two. And if two angles are complements of congruent angles, then the two angles are congruent. So next week I'm going to have you spend some more time memorizing these and knowing these inside and out. In order to do the proofs, in order to do the problems, you're going to need to know your definitions, theorems, and postulates inside and out. You don't have to memorize which number it is, you just have to memorize what it's saying. So like the midpoint theorem, we can just call it the midpoint theorem. The angle bisector, we can call it that. But when it comes down to theorem 2.3, you would just say vertical angles are congruent. You would just basically state the theorem in your own words. You could say vertical, you would say vertical, we could use that for angles, this for congruent to make it a little bit easier. All right, on to the homework. You can see that I'm racing to do this. So hold on one second. I left my answer key in my house. Hold on. Okay, so the first part of your homework. What I expect you to do for your homework is to work. You're going to have to work a little hard. You have to look in your book and find which definition, theorem, or postulate this is. So you should have it in a notebook, so you don't have to dig all through your book to find them. They're in one place. So let's go down through and see how we do on these. A lot of these are review. So this is your homework. I'm actually doing it, so we won't have to do it in class on this assignment on class. And you can pause it if you haven't done your homework and then start it back up and check it. So here we go. These start out the same ones we've been doing over and over. Hopefully you get in a rhythm with these and it's not as scary and geometry becomes fun. It's going to change as it goes. It's going to be, a lot of it is just learning the definitions, theorems, and postulates and applying them. So number one, AD plus DB equals AB. Now look, that's the angle addition postulate. We're adding two segments together, two small segments on the same line to equal the larger segment. So that is our angle, I didn't need to write that out, addition postulate. Or segment addition postulate, duh. Hold on. They're segments, not angles. Okay, so we got the segment addition postulate. All right, look, the next one, however, is angle 1 plus angle 2 equals angle CDB. That's the angle addition postulate. I hope you're getting these. Angle addition property. It's more like we're doing an English class than a math class in some ways. All right, now we have angle 2 is congruent to angle 6. Well, why is that? Well, that's that theorem, vertical angle theorem, that says vertical angles are congruent. So you can either put the vertical angle theorem or you can say vertical angles are congruent. Number 4, it says D is the midpoint. If D is the midpoint of AB, then AD equals half of AB. And that is the midpoint theorem. So the midpoint theorem is different than the midpoint definition. The midpoint definition would have said AD is congruent to BD if D is the midpoint. Then we have number 5. It says if DF bisects angle CDB, then angle 1 is congruent to angle 2. And that is the definition of angle bisector. Definition of angle bisector. I'm making a mess out of this. Okay, the next one, if measure of angle ADF plus the measure of FDB equals 180 degrees. Well, that's the angle addition postulate, because it says if it's a straight angle, Then these two smaller angles add up to 180 degrees. So that's your angle addition postulate. Okay, next one. It says if segment CD is perpendicular to segment AB, then angle CBD equals 90 degrees. And that one is the definition of perpendicular lines. I didn't read through the definitions, but you should have them in your notebook and you could read those. Definition of perpendicular lines. Definition of perpendicular lines says if two lines are perpendicular, then they form 90 right angles or 90-degree angles. I'm running out of space in here. All right, angle 4, if angle 4 is congruent to angle 3, then DG bisects angle BDE. And that's just your definition of angle bisector again. Of angle bisector. Number 9, if angle 3 plus the measure of angle 4 equals 90, then angle 3 and angle 4 are complements. That's just your definition of complementary angles. That's what it says. If they add up to 90 degrees, then they're complements. All right, measure of angle ADF, and let's see, it's not measure. Angle, yeah, if angle ADF and angle 4 are complements, or supplements, then they add up to 180 degrees. And that's just your definition of supplemental angles. It just says that. If they're supplements, then they add up to 180 degrees. Definition of supplementary angles. Number 11, we're getting into the new ones. If segment AB is perpendicular to CE, then angle ADC is congruent to angle ADE. And we just did this one. This is theorem 2-4. It's not new in this lesson. But if two lines are perpendicular, then they form congruent adjacent angles. Phew. So if two lines are perpendicular, they form congruent adjacent angles. The reason I can't write neatly on here is because I have it connected to the internet and it's a little delayed. Okay, the next one. If angle 4 is complementary to angle 5 and 6 is also complementary to angle 5, then angle 4 is congruent to angle 6. And we just did this one. It is the, what number are we on? Number 12. It is theorem 2-8. So I'm just going to write theorem 2-8 since we just did that one. Theorem 2-8 says if two angles are complements of congruent angles, then the two angles are congruent. Okay, number 13, if angle FDG is a right angle, then FDF is perpendicular to DG. So I got to look at this one. FDG is a right angle, then DF, this one, is perpendicular to DF. And that's just your definition of perpendicular lines, because it says if they're perpendicular, then they form a right angle, and you can go the other way around. If they form right angles, then they're perpendicular. And the last definition, yay, if angle FDG is congruent to GDH, oh look, these are two congruent angles that are adjacent, then they're perpendicular. And that's our theorem 2-5. I'm just going to write theorem 2-5 to save me some writing. Theorem 2-5 says that if two angles are congruent, then their adjacent angles are congruent, then they're perpendicular. All right, let's hit this proof real quick. Excuse my book, my kids must have written all over it. So copy everything shown and complete the proof. In the case where two angles are supplemented the same angle. So it's saying angle 1 and angle 5 are supplementary. So think in your head, what does it mean that 1 and 5 are supplementary? Well, it means that they're going to add up to 180 degrees. Angle 3 and angle 5 are supplementary, which means they're going to add up to 100. So that's what you should be thinking when you read this. You're going to think, oh, I'm going to say measure of angle 1 plus the measure of angle 5 equals 180 degrees. And we're supposed to prove that these two, we're just proving theorem 2-7. This is just like we proved theorem 2. I feel like we proved this one. This is one that we did prove. This is exactly like the one in the book. So here we have angle 1 and angle 5 are supplementary, and angle 3 and angle 5 are supplementary. So we'll put that, whoops, angle 3 and angle 5 are supplementary. So 1 is supplementary to 5 and 3 is supplementary to 5. So we know that 1 is going to be congruent to 3. So this is our given. Well, I did this problem. Angle 1 plus 5 is equal to 180, and angle 3 plus 5 is equal to 180, and that's your definition of supplementary angles. And then we set them equal. That was our substitution. Sometimes they use this reflexive property. I'm not a big fan of it. I would rather put this in here and call it the subtraction property. And then we're going to have by subtraction, whoops, that wouldn't be subtraction. You wouldn't need that step. Just put subtraction down here, subtraction property. So they're just doing this. This step is not necessary, but you can put the subtraction property. Okay, let's look at number 16. Are there any angles in the diagram that must be congruent to angle 4? Well, here's angle 4. We know that 2 has to be congruent to angle 4 because they are vertical angles, and vertical angles are congruent according to a theorem. So if angle 4 and angle 5 are supplementary, so we're going to have these two are supplementary, so I'm going to put 2 dots, and 2 is congruent to 4, we know that, we also know that, let's see, 4 and 5 are supplementary, they add up to 180 degrees. What other angles must be congruent to angle 4? Well, we also know that these would be supplementary, right? Because they add up to 180 degrees. So 4 and 6 have to be the same because they're supplements of the same angle. And then we would also know that angle 8 would be congruent to angle 6 because they're vertical angles. So since 4 and 5 are supplementary, and 5 or 6 are supplementary, supplements of the same angle are congruent. So 4 is congruent to 6, and then vertical angles would be 8. Okay, I'm speeding through here, guys. Hang in there, because I'm going to lose my battery in my computer, so it's not going to go on forever. All right, copy everything shown and complete the proof. Let's see, I don't know if I can make this bigger or not. It would be really handy if I could make this whole thing bigger, but I don't know if I can do that. Hold on. No, yeah, whoa, yes I can. Okay, hold on. That's a little bit bigger. Okay. I'm going to skip this one for now. I want to do a couple of these proofs for you before my battery dies on my computer. Seriously, that is my problem right now. So, we'll skip that one for right now. Let's do number 19. We'll do quick proofs. I'm just going to actually show you what steps. I'm just going to tell you what steps, and maybe you can write those out. So this one, you're given that 2 is congruent to 3. You're supposed to prove that 1 is congruent to 4. Okay, this is a very simple proof. So I'm going to have to get my charger. I had to go outside because there's too many people in my house, but I'm going to have to get my charger. So hold on, I can't pause this video, unfortunately. One sec. Just try that proof while I'm getting my cord. Okay, we're good now. Okay, so in this proof, we are given, let me just do it over here since I have a little bit more time since my battery's not going to die anymore. So we would have our statements. I want to show you how easy some of these proofs are. And as I said, it's okay if you don't get proofs yet. You're going to get them. So your statements are angle 2 is congruent to angle 3. And that's a given. So what else can we say? If we look at that, we know vertical angles are congruent, right? So we can say angle 1 is congruent to angle 2. And we can say angle 3 is congruent to angle 4, and that's vertical angles are congruent. Now look what we can do. We can do a little bit of substitution, right? So if 1 is congruent to 2 and 3 is congruent to 4 by vertical angles, and we know 2 is congruent to 3, we can substitute a 3 in for, where are we going? 1 and 4. 1 and 4. So we can say 1 is congruent to 2, and we can also say 4 is congruent to 2, right? We can say angle 2 is congruent to angle 4 because we're going to substitute the 2 in for the 3, and that would be substitution. And finally, we can say, since 1 is congruent to 2, I probably didn't need to do this many steps. We could say angle 1 is congruent to angle 4. So that's all by substitution, and we got to where we needed to go. Substitution. So we just substituted those in, and we got those are congruent. All right, let's look at number 20. Angle 3 is a supplement to angle 1. So angle 3 is supplement to angle 1. So you should be thinking measure of angle 3 plus the measure of angle 1 is going to equal 180. The measure of angle 4 plus the measure of angle 2 is going to be 180. So let's do this proof. Shoo, what I would give to have a nice, neat writing here. Sorry. Statements, reasons. All right, number 1 is angle 3 is supplementary to angle 1, and angle 4 is supplementary to angle 2. Okay, the reason for that is given. Everybody should have that written down. There shouldn't be any blanks on your pages. Okay, when you see supplemental, you know that the measure of angle 3 plus the measure of angle 1 is going to equal 180. And the measure of angle 4 plus the measure of angle 2 is going to equal 180. And that is definition of supplement. Supplemental, I can't say that word, angles. Okay, now we can set these two equal to each other because they're both equal to 180. This seems to happen quite a lot, so we can do this. Measure of angle 4 plus the measure of angle 2 equal each other, and that's substitution. I'm trying to see where we're getting to. And all we have to do is get to prove that angle 3 is congruent to angle 4. Now, we can also say, it's kind of in here, they don't tell us that, but we can see it. We can say the measure of angle 1 equals the measure of angle 2, and that's vertical angles. And finally, we can substitute right on in. We can say the measure of angle, who are we trying to get together, 3 and 4? Measure of angle 3 plus the measure of angle 2. I'm going to substitute this in for this measure of angle 1. Equals the measure of angle 4 plus the measure of angle 2. And that's another substitution. And then finally, we can subtract the measure of angle 2 from both sides, and we're going to get the measure of angle 3 is equal to the measure of angle 4, and then you can say your congruence. Angle 3 is congruent to angle 4. And the reason for that is substitution. Boy, that was a 6-stepper. That's pretty big for us. Subtraction, property of equality. All right, let's do one more. I think that's sufficient for understanding this. So 21, you're given that AC is perpendicular to BC. So that basically is saying that it forms a right angle. And then 3 is a complement to angle 1. So we want to prove that angle 3 is congruent to angle 2. Okay, I can see where we're going here. So let's get this going. I can scroll up just a little bit more. Anyone that's still with me, congratulations. All right, so let's see. Well, I may as well just get straight lines. I at least have power to do straight lines. All right, I hope no one ever watches this on YouTube except you guys. So statements and your reasons. We write our given. So we're writing segment AC is perpendicular to segment BC, and that is given. 2, since they're perpendicular, we can say that angle AC, let's say the measure of angle ACB equals 90 degrees. And the reason we can say that is because, well, I'm going to change that up. This is going to happen when I do proofs, or when anyone does proofs. You're going to like have a different idea. Like, I think I'll try something else. No, actually, I want to say that. Sorry. You can say the measure of angle. I'm just going to put more steps in. Just fail that way, like have more steps than less steps. So we're going to say the measure of angle ACB equals 90 degrees, and that would be definition of perpendicular lines. All right, then we're going to say the measure of angle 1 plus the measure of angle 2 equals the measure of angle ACB, and that is your angle addition postulate, remember? Where we would have the angles add up to the small ones adding up to the large one. Now we can say the measure of angle 1 plus the measure of angle 2 equals 90, and that's just substitution. We're putting the 90 in where that is because that's equal to that. So that's just substitution. I'm doing these on the fly, guys. So 1 and 2 equals 90, and then they tell you right here that 3 is complementary to angle 1. See, 3 is complementary. I didn't put that in my given, so I'm going to say angle 3 is complementary to angle 1, and that's given. Almost done. And 6, we can say measure of angle 3 plus the measure of angle 1 equals 90, because that's the definition of complementary angles. I hope I'm going somewhere. Okay, we're trying to get 3 is congruent to 2. Now, we can say measure of angle 3 plus the measure of angle 1 equals the measure of angle 1 plus the measure of angle 2. Ah, it's so beautiful. Okay, that's just substitution. They're both equal to 90. They're both equal to 90, so they're equal to each other. We're substituting. And then finally, we're going to subtract off this 1, and we get the measure of angle 3 is equal to the measure of angle 2, or angle 3 is congruent to angle 2, and that is just by purely and simply subtraction. Subtraction, property of equality. So I will spare you the third one. It's done really similar. You're going to just add the third one. It says 1 is equal to 2. Measures are equal, and 3 is congruent to 4. So you would say 1 plus 2 equals 2 plus 4 by the angle addition postulate. And then you would say that they're equal. The addition postulate, if they're equal, you're adding equals. So you would say 1 plus 3 equals 2 plus 4. And then you would say that the big SYZ and SYX are congruent. And then you would say they're perpendicular because of the theorem that says if the two adjacent angles are congruent, then the lines are perpendicular. All right, I'm going to end it there. I've been talking a long time. Probably bored you to death, but I hope that helps with your homework.